So, good afternoon, ladies and gentlemen. First of all, I would like to introduce about myself. I'm Kexin from Singapore Temasek Polytechnic, and today it's my great honor to be here to represent my group to do the presentation about our research thesis on the way. And you may be a little bit curious about why does this topic come out? Actually, the answer is very simple. As we all know, when we rush for some important days and meetings, taxi has become a very useful tool for us. But sometimes we may take a very long time to wait, and you may walk around to other crossroads without direction because you also have no idea about where the available taxis are. So finally, what you have is because you waste a lot of time to take a taxi and you may be late for your important days or meetings, your boss and friends may blame you, say, hey, why you come so late? Why you let me to wait for such a long time, right? So we think that taxi on the way can perfectly fix this problem, and we come up with a presentation online. It's a 20 minutes presentation, which including the following parts. And actually, this presentation is not very technical type. It's more like an idea sharing section, so you may be a little bit relaxed for the following 20 minutes. And let's start now. So let's come to the introduction part. As taxi has played an increasingly important role in people's life and become one of the most popular travel mode in modern society because flexibilities and convenience. So what we are going to do is to use Scilab as a main tool for development to combine the taxi booking and calling system together. So we believe that our system will be very beneficial for both taxi drivers and users. So as we use Scilab as a main tool, which means some algorithms will be done using Scilab to do some calculations like the traffic light off period control and the estimate arriving time and some other basic calculations. So, and some graphical charts will also be done using Scilab to show some data to user for better visualization effects. And there is no doubt that in order to achieve make our system be fully functional, we still need to take use of other software and existing technology like GPS to achieve. But next, why do we need such a system and why do we need taxi on the way? These two main reasons we will discuss in the following slide later. The first one is the current situation, as it's a very common phenomenon that taking taxi for pedestrians has become a really difficult thing because your waiting time will be much more longer during the peak hours and under some bad weather conditions. So we feel that the improper waiting style of taxi driver has also contributed some negative effects. They used to wait customer at his familiar and common place, but unfortunately, sometimes these places are not very urgent needed about taxis. So, after some research, we found that one of the main reasons caused such current situation is the information asymmetry between the drivers and the pedestrians, which means they do not have a very fresh information about each other. The taxi driver don't know where the taxis are needed, and the pedestrians also have no idea about where are the available taxis. So we think that one of the best solutions is to create a common platform that can enable the user to make some requests like calling or booking taxis. At the same time, also provide some chances for taxi driver to accept the order and get customer without too much waiting time. So it's also be very helpful for improving the performance of taxi distribution of whole city, as taxi on the way is conceived to better utilize the taxi resources of the whole city, and it can make it be more efficiently. And so how to use our system to call a taxi is just few simple steps. Firstly, you need to sign in an account with your own information like your telephone number, your name, and so on. Then you need to choose your starting point and final destination. And after confirming all the information you provided before, once the taxi driver has confirmed your order officially finished here. But our system will show you the estimate arriving time for taxi to your current location and to your final destinations. So you can have a pre-understanding about your travel details, like when can I get to the destination and I won't wait for the taxi. And besides that, we also show the actual traffic flow chart for users' information so they can manage their traveling routes, make it more efficiently. And the taxi booking system actually is very similar like the calling system. Sign in an account with your information and choose your traveling date and time, then choose your starting point and destination. The main difference between these two modes is our system will show you the predicted traffic condition plot before you confirming all the information, which means you can use this plot to finalize your traveling time, to finalize your traveling date, to make it you can avoid the traffic congestion period and make your traveling more efficiently. And the last one is confirm all the information and you finish your booking and you just need to wait the taxi on the traveling date. This also the special features that make our system stand out from other similar apps or websites. For taxi calling system, the traffic light on-off period control make our system very special. And for taxi booking system, the predicted traffic flow plot also make our system stand out. So, what exactly the traffic light on-off period control is? We will customize the traffic light on-off time according to actual traffic situation and at different time slot at different place, which means we will input some necessary data like the time and the actual traffic flow at this crossroad to our calculation system. And after that, our system will automatically calculate the most reasonable and scientific green light on time for this direction, which means the traffic congestion can be greatly eased. And then, since we have know the traffic light on-off time combined with the actual taxi location, we can know the estimate arriving time. So for better illustration, I would like to use this picture to do an example for you. Which, let's say the time now is 7 p.m. and there is a customer ordering taxi at Temasek Polytechnic Main Gate and Tampines Avenue 5. And the nearest available taxi is waiting for green light at Tampines Avenue 4. So we input the necessary data like the 7 p.m. time and the actual traffic flow for this direction at this main crossroad into our calculation system. And we can get the green light on time at this moment for these directions. And we assume the distance between the taxi and the crossroad is around 10 meters, and the average speed for taxi to pass through this crossroads is around 30 miles per hour. And we can use the primary one mathematical knowledge to get the time taken, which is equals to distance divided by average speed. And use the same way to calculate the time taken for taxi to pass through the Avenue 1 distance to the user current location, and we can sum these two values up to get the final estimate arrival time to the user current location for taxis. So how our calculation system like, how to do the calculations? This is the mock traffic flow variation charts, and the horizontal axis shows you the time within a day, and we just take out the period the traffic congestion normally happens to make it more clearly for your analyzing. And the vertical axis is the actual traffic flow for crossroad. And we ignore 3 other directions and focus on analyzing the traffic condition for 1 direction. So as you can see from this chart, the traffic flow has a great change during the peak hours. And if we set the below this line, like the normal traffic flow for this direction at this mean crossroad, and set the green dot line M as the largest affordable car number can pass through this crossroad during 1 cycle of green light on time. And which means if the traffic flow is larger than this red dot line, traffic congestion caused, because too much cars waiting for the green light and they cannot pass through during 1 cycle of green light on time. But during off-peak hours, there are some spare car number that can pass through this crossroad during 1 green light on time, which is a green shadow area. So what we are going to do is to try to make the difference between these 2 areas as small as possible to balance the traffic condition within a day. So what we are going to do is we design an objective function f. The L1, L2, L3, L4 here shows you the green light on time for 4 directions. And the A1, A2, A3, A4 here is the difference between these 2 shadow area for 4 directions. And how to calculate the A numbers? A numbers is actually the difference between these 2 shadow area, right? And we use A plus to represent the red shadow area and use A minus to represent the green shadow area. And the red shadow area can use the trapezoid error formula to get, which is this expression. In the green shadow area, we can use the triangular area formula to calculate. After that, we will do the subtraction and do the simplification for these 2 expressions and get the final expression for A. And when we need to do some real calculations, we need to substitute the very improper number into this function for 4 directions and substitute the 4 terms back into our objective function. And we think we can use the PSO toolbox of Scilab to do the calculation and get the result. So after that, since we have get the traffic light on time according to the actual traffic situations, and we can combine with the current location of the taxi, do some very simple calculation using Scilab to know the very accurate estimate arriving time for taxi to the user current location and to user final destinations. And then the predicted traffic flow plot must be mentioned. So what is it? We will use the average value for past 3 weeks traffic flow as the next week's predicted traffic flow, which means, for example, if we set the past 3 weeks traffic flow at 7 p.m. on Monday as M1, M2, and M3, we use the average formula to get the average value for these 3 numbers, EM, equals to M1 plus M2 plus M3 divided by 3. This value can be used as the next week predicted traffic flow on Monday at same time, 7 p.m. and at the same place. So we will use the very same method to get the whole day predicted traffic flow for next week. And we can show this to the user, and the user can use this plot to manage their traveling routes more efficiently, because they can use this plot to avoid the traffic congestion period and choose the traffic condition good road. And next, Before we launching our system into some specific cities, there are some researches we need to be done before. The first one is the data recording, which means we will do some counting and recording about the data of the needs about the taxi at different place, at different time slot, and generate Excel like this, including the item like number of people taking taxi, their average waiting time, and their traffic flow at this place and at this period. After that, we can use Scilab to read this data from an Excel and generate the line chart using this data number. So, since we can analyze the charts in advance, we can know where the taxis are needed around what time. So, we can distribute the taxi in advance according to their actual situation. Next, and we will also do some questionnaires among the citizens at that specific city. So about their viewpoints of our system and how our system can be improved. And all the results of the questionnaires can be used Scilab to change into the form of line chart and bar chart in order to make it be more clearly. And yes, finally is conclusion. We believe that our system is very essential system and can provide the convenience to both users and drivers, and it also be very helpful for optimizing the taxi distribution of the whole city. And most importantly is today I'm here to share with you about our new ideas, and I hope our new idea can inspire some people's mind who are very interested in such system. So more people can get together to concentrate on working the technical area about our system and to make our system can put in use in very near future. And that's all, and thank you for your attention.